Hello everyone and welcome back to another video. I hope you all are having a fantastic day once again. If this is your first time watching one of my videos, thank you for stopping by. We are in the middle of a very long running series where we're building a complex web application from scratch. So if you haven't seen any of these before, check out the other videos on my channel to get caught up. We've done quite a bit so far with setting up AWS infrastructure, a CI/CD pipeline, doing DevOps stuff, setting up code repository, all that fun stuff, doing some coding development work in Java, all kinds of fun stuff. So hopefully you all have been enjoying these videos so far. In this video, our goal today is to basically get a framework put in place of a factory pattern within Spring. So I guess I'll explain a factory pattern a little bit and some of the struggles with doing this within the Spring framework, and hopefully code out a solution for that within Spring. So hopefully we can get through this in about half an hour if I don't talk too much, but let's dive into a little bit. So a factory is a design pattern where you create objects and return them to whoever needs those objects. So think of it like a physical factory for a car. It just produces cars over and over and over again, and whenever you need a car, you call the factory and it spits out a new car. A factory in Java or any language that has a factory pattern is similar. You tell the factory what you want it to make, and the factory return you back the object of what you asked for. And so the purpose of it really is to abstract away how to make the object. So the factory knows how to make it, but you as a client or whoever calls your factory doesn't need to know all the ins and outs on what constructors are available, what patterns it's used behind the scenes to create those objects. It just knows if I give it these parameters, it returns back a object that I want. So that in general, very high level, is a factory pattern. And again, one of the usefulnesses of this pattern is if you were to always call like the new keyword and just create new objects everywhere in your code, right? And you ever want to change the constructor for that object or have the object be created in a different way, you have to go back through all the places in your code that you've created that object and update all those signatures, all those calls to match that new way of creating those objects. Where in a factory pattern, the people needing the object doesn't change. So they just still call the factory pattern that they always do, but the factory itself can make a change since it knows how to create the objects, and it's isolated in one place to make a change to return back an object. So hopefully that's a little bit clear for you guys. If not, just let me know in the comments below and I can explain it more in future videos. But I'm hoping part of this is building an application from scratch with you guys, and part of it is teaching and just sharing what I've learned throughout my career with you guys. So it's part teaching and part learning. So next piece. So a factory pattern in Spring is a little bit more difficult. With Spring, whenever an application starts up, it creates all of those beans, all of those objects, and puts into the Spring context at startup time. And then whenever your application needs those beans, it gets wired in, it gets injected, dependency injection, and then you use those beans. If you were to create new objects during runtime, it will not have all of those wired dependencies come in to those objects. So if you have, I guess an example. So this retrieve token class that we have, right? If we have a factory that calls retrieve token and just creates a new token every time, a retrieve token class every time, it may not be able to wire in this REST template bean because you're doing it at runtime and it's already instantiated the Spring context and loaded all those beans up in its context and won't know how to inject in things at runtime. So hopefully that makes sense to you guys. Again, this is getting a little bit more advanced Spring, but that's sort of the struggle with Spring using a factory. So we cannot use the new keyword in our factory to return back new objects within the Spring context. So there is a clever way around that I found a while back, and I don't recall the blog or the Stack Overflow page that I found this from, but I remember the high-level components of it. So hopefully we can do that here together and get a Spring pattern, Spring factory pattern, I guess would be a good way to say it. So we're going to do this a little bit test-driven development approach. I'm not going to start with unit tests though. This is going to be very dependent on Spring and wiring things in correctly. So we're going to go ahead and start with an integration test for our factory. So in our test package down here, go and right click, new Java class. We'll say this class name is Robinhood Factory IT. IT again is for integration test. It's put this class under our authorization package. It's just how this has been nestled together. So we'll right click this and refactor, move, and take out the authorization part of it. So this is going to be in the Robinhood package. So if I expand this, it's going to live at this location. And I guess the purpose of this factory real quick is whenever we want to make a call to Robinhood, we're going to pass in the request and what call we make to our factory, and our factory is going to know how to invoke that call for us. So this will abstract away all of the clients of this guy. So the retrieve token, buy orders, sell orders, account details, open positions, all those different client calls will go through our factory. So first thing we need is a Robinhood factory class. So private Robinhood factory, we'll now call it Robinhood factory. So this no longer compiles because this class does not exist. So let's fix that real quick. Go up here, new Java class, Robinhood factory. Zoom in a little bit, zoom in here a little bit. There we go. Again, this put it in the wrong level for our package. So we'll right click, go to refactor, move, take out authorization, hit refactor, and here we go. So now we have our factory class. It compiles, everything is good. This is going to be a component, so we want Spring to manage our factory. So we are going to do a couple things. Let's see, we need to do at autowired. So we want to autowire in the factory. And in order to autowire in the factory, we go back to our factory and we'll do at component. So component is a type of Spring bean. It's just nomenclature. It's called a component. does the same exact thing as calling it service, like our retrieve token does at service. At component does the same exact thing, just a different name to do the same thing. All right. So next we need in our factory a method that will take in a couple pieces of data and return back a response. So we're going to, in our integration test, code what that should look like. So at test, public void test, let's say invoke test. And real quick before I forget again, Spring Boot test up here, and at run with Spring Runner dot class, alt enter a couple times to import those in. So this will have our annotations and Spring context loaded for our test class. All right, so down here, we're going to define here as a test class or a test method what our method will look like that we want in our factory. So it's going to return a client response. So that client response will equal our Robinhood factory dot invoke, and here is going to take in two parameters. One is going to be the call, so I'm going to say that is the broker call. So this is going to be an enumeration that we'll define in a moment, but it will look like this. So actually we enumeration, so we don't need that. Define up there. We can say broker call dot Robinhood login, and the second argument is a request object. So that will look like what? Let's go to our retrieve token integration test, and it will look like this. So we'll just copy over the same method for now. We might try to clean this up to not copy paste code, but for now it should be okay. So call that from in here. So I think this is what I want our signature to be. And real quick, login data extends client request, and that's really what I want for this second argument. So the way this is going to work is we're going to call our factory. It's going to have an invoke method on it. We want to pass in basically what class or what client I'm wanting to do. So I want to log in to Robinhood. So we'll define this enumeration here in a moment. And then the second argument is a client request object. It's our payload that we're going to give our service class. All right, so obviously this does not compile because we haven't defined any of this stuff. So let's start to remedy that a little bit. So quick one, let's go ahead and define this enumeration. And I think a good place for that to live is under the client package. So as we add in more brokers, we're going to have like an E-Trade login, Robinhood login, TD Ameritrade login, all these different types of brokers, each with all their different calls. So instead of putting it under the Robinhood package, we're going to put it under the client package. So we'll say new Java class. So our name is going to be broker call, and it would be an enum. Say OK, and that creates this enum. Zoom in a little bit. There we go. So enum, you can look up on Google how it all works in Java. But in our simple case, we just want to define an enum where the entry can contain Robinhood login. All right. So go back to our integration test. Go to our broker call, Alt-Enter. It can now find this field. So we now have defined it in our broker call enum. So that looks good. The last thing we need to do in order to get this to compile is to define this invoke method on our factory. So let's go over and do that real quick. Go over to our Robinhood factory. We're going to have a public method. It's going to return back a client response object. The method name is invoke. I'm going to go ahead and fill this in and say return null. And for our arguments, we're going to take in a broker call object and a client request object. Do Alt-Enter to import both of those. And now our class here compiles, and our integration test also compiles. There's no red underlines, no red over here. So everything is compiling, and we have the beginnings of our factory setup. So let's think through what the next piece of our factory is. So we're going to have a switch statement in here that will go through the broker calls and figure out which client service class is being needed, and then pass in the request to it. Do I need to do that? I don't think I need to do that. Let's do it this way first. So I need to have our factory know all of the classes that can have client calls. So right now we only have one, retrieve token. But in the future, we're going to have multiple calls to different APIs, and our factory needs to know about those calls. So let's, and Spring has a really neat feature, so where you can auto wire. So we'll do an auto wire annotation, private. We're going to auto wire in an abstract class, I believe. So why don't we take out this for now and do it in this way. So we will create a new class under the Robinhood package. We'll say Robinhood calls. Say yes. And this is going to be an abstract class, so we do not want to instantiate this class at all. This is going to be a little trick for our factory to auto wire in different things. So now that we have this abstract class, we're going to go to our retrieve token service, and this is going to extend our Robinhood calls class. So we'll import that in. And whenever we add in a new call to Robinhood, say our next call is to get our account data, we will then create a new service called account data or whatever it might be, and we'll also extend the Robinhood calls. So anything that extends this abstract class would be a collection of all of our Robinhood calls that we are making. So now let's go back to our factory. And we're getting a little bit away from TDD for this kind of stuff, so I'm kind of thinking through this as I go along. So bear with me a little bit. So now we can do our @AutoWired, be private, and we're going to wire in all of our Robinhood calls. And this trick is a way to where when Spring looks, it'll look at any class that extends this abstract class and inject it in here. So this needs to be a list of Robinhood calls. So look for anything that any class that extends this Robinhood calls class, and it'll inject it into our factory here, which is great. So next, we still don't know how this invoke method will know which member of this list to actually call, right? So we need a way for this factory to know that information. So we're going to do that not two different ways. We're going to add two things to our abstract method. So first, we need a public let's see, our retrieve token. So we'll need this method. We'll copy this over. We'll make this method abstract, so anything that extends it will create this method. So login data, this is going to be client request. I think that looks right. And our second one, we're going to add a new method, public abstract. This is going to return back a broker call, and we'll say get broker call. Okay. So I'll try to explain a little bit what this is going to be doing here in a moment, and hopefully you'll see all these pieces tied together at the end. So now that we've added this method, we need to update our retrieve token class so it no longer compiles, because we are no longer satisfying our abstract class. So we've defined this. Let's not do that. We've defined our this method, but we have not yet defined our getBrokerCall method. So we'll go over here. We will add in the method, and we'll go ahead and do add override here just to make it clear that this is overriding a method. We'll fix this here in a moment. So this is going to self-identify what call it is making. So it's going to return Robinhood calls, nope, wrong one, broker call dot Robinhood login. So this is declaring that this class is for broker call dot Robinhood login. Okay. So next, I believe the issue here is this is login data, and it probably wants client request as the input here. So how do we make this compile? Can we just typecast it? Yeah. So we know this client request is login data type. So we'll just typecast that into that object. And this now compiles and it's good to go. I think everything's compiling at the moment, which is good. All right. Something I don't quite like at the moment is this guy. So it's an abstract class. It just defines a couple things. So we're going to change this to an interface. Get rid of abstract, get rid of the public, Control Alt O to clean up imports. That looks fine. Let's go to our retrieve token. Instead of extends, it will be implements. And everything is happy again. So I prefer to use interfaces instead of abstract classes where possible. So now we are doing that. So we still got a little ways to go. It's going on 30 minutes. Hopefully I can get the rest of these pieces at least coded, and we'll probably do our unit test, integration test around it in a different video. We were almost done with our factory though. So now we have a couple options. We could create a for loop in here that iterates through our list and finds and calls the get broker call, compares that to our input. Whenever it finds that match, then it would know that it's a correct service and passes in client request. The invoke method returns that, and that'd be good to go. But that's going to be iterating through that for loop over and over and over again every time you want to make a request. That's not too performant, but there is another trick that we can do to speed that up. So another option set of a list is a map. So a map is just a key value pair. So our key will be the broker call we want to make, and the value will be the service that has that call. So we can make a private map of broker call Robinhood calls. So I might want to change the names around to make this consistent, not single and then plural, but we can do that later. The variable name would be mapped Robinhood calls. Alt enter. Java.util for map looks good. All right. So our list is auto-wired, but our map is not auto-wired. So right now this is null, right? So if we try to get the broker call from this map, it would throw a null pointer exception, and that's not good. So what we're going to do is do a private void populate mapped Robinhood calls, and here we're going to create our map. So we'll say map Robinhood calls equals new hash map. We're going to iterate through our list. There's a variety of ways to do that. You can do a for each, you can do an iterator, you can do probably a string as well, which would be interesting Java 8 thing to do. But just for simplicity's sake, we'll do for Robinhood calls and Robinhood calls. And then, so we'll go through each one of those items in our list. We're going to do map Robinhood calls dot put, where the key is calls dot get broker call, and the value is calls. So this will say put in my map whatever my class self-identifies as and itself. All right. So after this runs, our map would be populated with all of our Robinhood calls that was auto-wired in because they extended or implemented rather this class, and our map would be populated with those calls and a way to access it quickly and not iterate through every time somebody calls invoke. But we need a way to trigger this method. There's an annotation, I believe this is a Java 1.8 annotation. Where are you located? Yep, just comes in with Java 1.8. And this post construct, what this annotation says is, after this object's been created, run this method. So it's been auto-wired in when it's created. So this is not null, it's populated. So before anybody uses this object, this triggers and then populates our map. get rid of some white space here. All right, last step. Well, a couple more steps. We're going to do a happy path for this video. So we'll assume our broker call exists in our map. Probably in our next video or next couple of videos, we were probably going to add in some exception cases to where we pass in something invalid that our map does not contain, and we'll make sure that throws a proper exception back. But for now, I can call map Robinhood calls dot get my broker call, so I'll retrieve it from the map, then dot invoke client request, and return that back to whoever calls this. And this should be all that I need for my factory. So let's do a quick look here. And I'll do a system.out line and say finish test. I'm just doing this to add in a breakpoint here to see what this response object contains. So that's good. Let's do a little bit of logging. So we'll use our logging framework we put in last video. Private logger. Let's do private static final logger, all capital logger, equals logger factory dot get logger Robinhood factory dot class. So we'll do that. And then I think this would be a good thing to log. So we'll say logger dot, we'll do this at info level. It could be debug level, but info just let us know that this should only print out once. So once this factory is created within Spring, Spring is a singleton by default. So this factory should only exist as an object in memory one time. So this method should only get invoked one time, and this logger info statement should only get invoked as many times as we have Robinhood calls. So we'll say populating mapped Robinhood calls with service. Then we'll say calls dot get broker call. So this will tell us which broker calls are in our map. So that looks fine. So we have our list auto-wired in. Our factory itself is a component, so Spring will manage this class for us. It has an invoke method. We pass it in what call we want to make and a payload to it. It goes through our map and gets the appropriate service and invokes that guy for us and returns back that response to whoever calls our factory. And we create our map down here. So everything should be good to go. Let's go back to our integration test and let's put in debug and we'll see what happens. Fingers crossed, first time, hopefully it works. And down here it says it's building, so it's going to take a little bit to compile and build everything before it runs the integration test. So it's kicking off our integration tests. So hopefully it'll spin up a Spring context without any issues. We already see our logging statement. So if we go back to our console, bugger. I did notice it came up that it printed out our message, but in any case, we got back our token. So this is again an integration test that we copied over from our Robinhood login call. So this actually invoked Robinhood to log in and retrieve back a successful token through our factory. So yay, it all worked. We'll hit resume. I would like to figure out why it took out all of our logging in here for our other classes at some point. So I want to see all of our other log statements, but for now this was fine. Alright, so what else do we want to do for this video? One other quick tweak, and this shouldn't take too long, is in our test controller we are wiring in our retrieve token class itself. So here, instead, I want to auto wire our Robinhood factory. We'll rename that. We'll see what fails to compile. So this guy, so factory.invoke. And here we're testing login. So this would be broker call.robinhood login. And there we go. That's all we needed for this. So hopefully you all notice with this change, by wiring in our factory, once we have 5 or 6 or 7 calls to our Robinhood API, we won't have to wire in each of those classes here. We'll only have to wire in our factory and then call whatever service we want to run and pass in whatever data we want to have it execute on. So a quick recap, how is this going to look going forward? Whenever we want to make a new call to Robinhood, our steps would be to add the call to our enumeration, create a new service class, just like our retrieve token, do the add service annotation, have it implement our interface that we've defined, and then just have it override the 2 required methods. So one would be have it self-identify what the purpose of this class is, and the other is to actually perform whatever it is that it's doing. And it will take in whatever payload for the request, and it will return back a response object, and our factory will never have to change. So this will be scaled up indefinitely as many services as we want, as long as it implements this Robinhood calls interface. So this should be a one-time thing for this factory, which is great. It's very scalable. It's like maintainable. There's nothing else to do to this factory. So all of those are great things. In the future, as we add in other brokerages, we will probably have a abstract factory pattern, And we'll go into more detail when we get to that bridge, but basically we'll have a factory higher up under probably the client package. We'll have a factory that knows about the Robinhood factory and the E-Trade factory and the Ameritrade factory and the Webull factory and whatever brokerages we have, and it'll call those factories to do whatever method or whatever call it needs to do. So it's sort of a factory within a factory, and that is in essence an abstract factory pattern. So it's going on 45 minutes, so I don't want to take too much more time, but let's do a get status. So we've made lots of changes. We'll do a get add dot to stage all of the new and modified files. And we'll commit this to our develop branch, and we'll say refactored code to be a factory pattern, and we'll push this up. Normally you wouldn't want to merge this into master until you have all your proper unit tests, integration tests, and tested, done and complete. But I want to go ahead and kick this off and merge this into our master branch. Next video, we will go in and fill out all of our test cases, and again maybe do some error scenarios. But I want to pull in what we've done and have it deploy. So again, it only deploys changes to master. I want to make sure that this works live in our AWS infrastructure. Can I create a pull request without title? That is the question. Apparently not. Refactor to have, I guess, to be a factory. There we go. I'm curious what this Code Guru reviewer would have for this pull request. So this is a lot of different code, implementing a factory pattern, doing some fancy Spring things. So I'm curious if it would have any suggestions for me. But I don't want to wait a long time. So we're going to go ahead and merge. Get this build kicked off. So we don't want to delete. Fast forward to merge is fine because it's only one commit. Hit merge. And success. So now I'm going to log into the console. Well, let's sign out. Log into the console as the admin account. Go to code pipeline and follow this along real quick. And I have Postman up as well. So as soon as this is complete, we'll make sure we can hit our endpoint, and nothing should have changed. We use Refactor to do a factory pattern to abstract away our call. All right, it's built. So now it is deploying to our environment. Thought it was complete. Let's look at it again. Yeah, succeeded. So send request, still pass. So everything still worked just fine. Awesome. All right, so that's pretty much it for this video. I'm going to, I guess, review this real quick for anybody that wants another go around of what's happening here, since it's doing quite a bit. But thank you all for tuning in. Let me know what you all think of this pattern and think of what we've done so far. Leave some comments below, subscribe, like, all that fun stuff. Hopefully I'll have the blog series caught up by the time you all see this video. So in the description should be the blog post that has all these code snippets in there, and you can follow through as we do all of this fun stuff. So thank you all again, and again we'll go through this real quick just to review how this pattern is working. So we have create an interface called Robinhood calls. Anything that implements this interface has to have two methods. One is invoke, one is get broker call. The invoke method would be the method called to actually invoke our endpoint that we want to invoke and return back the response with whatever data that we pass into it. The get broker call is a way to self-identify whichever class implements this, what call it is attempting to make. So our broker call is an enum. Right now it just has one entry, Robinhood login. We will add in more to this as we add in more calls. So then we have updated our retrieve token service. Now it implements that new interface. It had already had this invoke method on it. We just changed the signature to client request, and then we typecast to login data, since we know that's the data coming in, that's the actual object coming in. And then we added in the get broker call, and we said that this class is returning a Robinhood login call. And then we created a factory called Robinhood Factory. We allow Spring to wire in a list of anything that implements this Robinhood calls interface. So this will have a list of any classes that implements the interface. So that'd be our Robinhood login for now, and it'll be all the other Robinhood API calls that we code in the future. To avoid doing an iterator every time we need to invoke a method, we created a map where the key is the API call that we're going to make, and the value is the service class itself. We added a method to populate that map. So we instantiated a new hash map. We iterated over the list of calls that was auto-wired in. We call it put, so to add in a object to the map where the key is whatever API call the class self-identifies as, and the value is the call's class itself. And then we have the invoke method. So this is what clients that need to make these calls, they'll call invoke. They'll pass in the call they want to make and the request object, and this will return back the response. So that is our factory. It's a component, so Spring will manage this factory for us. We added in a simple logging statement to say what calls have been included in this factory. And then finally, we had an integration test, but we also updated our test controller to auto-wire in the factory instead of the class itself. Probably need to clean up the imports at some point. And so now this is using the factory instead of injecting in the individual service class itself. A quick note, a pitfall to be aware of: our retrieve token self-identifies itself, and our factory creates a map with that as the key. So there is a possibility if I created another class, I don't know, called retrieve token 2, that also implemented that interface and also returned back Robinhood login with this call, then our factory, there's going to be 2 items in the list. One is retrieve token, one is retrieve token 2, but our map will only contain 1 item because our map is a unique set of keys. So whichever one was last in this for each loop would be what sticks. So it's a unique key. It would just be updated with the second entry in that list. All that to say, we need to be aware of that pitfall and make sure that when we call this method that we return back a unique key for this service. So we don't ever want to return back the same broker call enum field from 2 different classes. That would be very bad. So I think that's it. It's just a quick overview again of what we did today. If you want me to go more in detail on any of these pieces, let me know as well in the comments below. But we are going on an hour again, so I'm hoping to get these a little bit shorter, but at the same time, I don't want to chop up these kinds of videos when it's a specific topic, like a factory pattern. But now that we have all these pieces in place, we have a logging framework, we have our factory pattern in place, we have a successful Robinhood API call. Our next video will surround our factory a little bit more with unit tests, integration tests. Now wrap up the factory portion of this code, and we will start adding in more and more Robinhood API calls into this factory pattern. So again, thank you all for watching through this. Let me know what you all think, comments below, subscribe, like, again, all those fun things. And until next time, have a great day. Thanks. Bye.